Okay, so we're going to be looking at the inverse square law and how it pertains to light. And if you hang with me towards the end, I'm going to show where we zoom in on some stars and where it's really a law of perspective to see more stars. So some things about the North Star, that's what we're looking at. It's right above the North Pole. It's 433 light years away. And 1 light year is 6 trillion miles. So that's quite a distance. Just to give you a reference of how long it would take to get there, it took to the supposed moon landing 4 days to go from Earth to the moon. And as far as in measurements of light speed, the moon is less than 2 light seconds away. I think it's 1.8 light seconds away just to get to the moon, and that took 4 days supposedly. So the narrative we're taught is that we can see the North Star, Polaris, because we're not actually seeing the object, we just see the light from the object. Well, I mean, that's a cop-out. That's how everything works. That's how we see altogether, and there should be a massive amount of parallax, and there's not. So let's dive into this a little bit and see what we come up with. Okay, so let's look at the inverse square law. So we have our light source here. So let's say it's the North Star, and we have our diverging light from it. Our diverging lines here represent the line. The lines represent the light leaving the source. And so if we, draw a square in here, so let's say this distance here, the first distance, is 1 light day. So light travels at 180,000 miles per second. So let's just say this is 1 day. So this luminosity value is at 1 day. So 1 light day. So if you travel at the speed of light for 2 days, you double that. Now you've got, so this bottom line here, the size of it would be twice as long, and this height would be twice as height. So you're going to square that, so you have 4 times the area. So this whole area is still going to, have light, but it's going to be at 1/4. So the luminosity of this area at 2 days out will be 1/4 of where we started at 1 day out. So now if we go 3 days out, now we're at 1/9 the area. So the luminosity, I'm sorry. So it's going to be, the luminosity value is going to be 1/9 of where we originally started, and that's just 3 days out. So if we went 4 days out, it'd be 1/16. The luminosity would be 1/16, and 5 days out would be 1/25 luminosity from where we started here. Now that's just 1/25 of luminosity. That's just 5 days out. Imagine if you went for an entire year. I mean, the numbers would be crazy. There's no way you'd be able to see it after 1 year. Now do that 432 more times. So the idea that the luminosity would reach the numbers that they're saying, 433 light years away. 1 light year is very nearly 6 trillion miles. So I mean, one can't even imagine 1/6 trillion miles in your head what it looks like, and that's just 1 light year, 6 trillion miles. Okay, so if you look here, when we zoom in on the Big Dipper, notice all these other stars come into view. And I guess my question is, why don't you see these other stars with the naked eye as well? I mean, if you keep going and building on that, eventually there should be no nighttime. You should just always see stars lighting up the quote-unquote night sky. So obviously that's ridiculous, but a lot of people say, well, the light hasn't reached us yet. But if you can sit there with a telescope, and I've done it too with the Walmart telescope, hit on a clear night, hit a empty, what appears to be an empty space, and zoom in, and you can suddenly see more stars. So for me, this says the stars are very nearby, and this is perspective, because when you zoom in on something, it opens up your angular resolution, is all you're doing. The light's already there, you're just broadening that angular resolution. And to me, I think that's an example of what we're seeing here. The stars are nearby, or close, and or at least not near as far as what we're being told. And that's how you can zoom in and see more stars.